We're now on section 1.6, which is just simply labeled more equations and applications, right? So more equations, that's just more different types of equations that we can solve. Like I said, Unit 1 is just all about different types of equations, and we've talked so far about linear equations and about quadratic equations. This is just some more types of equations. One more type of equations that we're going to solve immediately is polynomial equations. That's in the next couple of slides. We're also going to see rational equations. Those are going to look familiar, but we're going to have a couple of extra things to do there. And then some things that don't look familiar are going to be absolute value and radical equations. So those are going to look a little bit new, but they're not anything any more difficult than what we have been doing. So starting with polynomial equations, anytime you have to solve a polynomial equation, the way that we're going to do it this unit is we're just going to solve by factoring. We are going to see some more methods in, I believe it's chapter 3 or unit 3, but for now we're just going to solve all these by factoring. If you go back to the review of factoring and see, we don't have a GCF in any of these, right? So we're trying to first take out a GCF. There's nothing we can take out of all four. Since it's 4 terms, we're going to do grouping. So 2 terms and 2 terms, we're going to take a GCF out of each. If you need to go back at any point and review those factoring methods, you absolutely should. And out of the second 2 terms, I can take out a 3. Remember, that middle sign is always going to come down. And you're hoping, whenever you're doing factoring by grouping, you're really hoping that these two match up. If those two match up, you've done something right. Why did I take out a 3 there? This is not 3. The GCF there is 9. If you take out a 9, you get x plus 3. And then we keep an outside group, and we keep an inside group. And then we'll factor as much as we can. This is already as far as it can go, but this one right here we can break down into 2x minus 3, 2x plus 3. The x plus 3 is just going to come down with the rest of the problem. Once we get to that point, we can still use that zero product principle that we used with quadratics. If we have a times b times c equals 0, then we know that one of those is equal to 0, right? If any of them equals 0, then we have a true equation. So can we find out what would make any of these 0? This one right here is an easy one. Negative 3 plus 3 would be 0, right? Here, if you set that equal to 0, we don't have to do this every time, but 2x plus 3 equals 0. Subtract the 3. 2x equals negative 3. X equals negative 3 over 2 when you divide by the 2. If you did the same exact thing here, you would get positive 3 over 2. I mentioned in the quadratics lesson that typically whatever your degree is, that's how many solutions you want to have. So here, since our highest exponent is a 3, we hope to get 3 solutions, and look at what we have here. Whatever our highest exponent, our degree, is how many solutions we want to get in the end. Here's another, solve this polynomial equation. Remember, if we have a polynomial equation, the easiest way to solve them, if it's possible, is to get everything equal to 0 and then factor and use that zero product principle. So the first thing I'm going to do is subtract 16x squared to both sides to try and get it equal to 0. It's not a like term. And now we'll take out a GCF. Always take out a GCF if you can. And now we'll try and factor some more. So this we can factor. 2x squared will just hang out. That's cubed, so again, you can go back and review the factoring lesson. And with cubes, we always have SOPs. And so to get this SOPs term is going to be x squared plus 2x plus 4. Now to find our solutions, that would be a 0. We do want to have 5 solutions here, and actually this 0 counts twice because we have x squared, that's the same thing as x times x. So really we have 0 and 0. We have 2 zeros here, right? Whenever you list out your solutions, you only have to list it once, but just keep in mind that there's 2, it's listed twice. Technically, it's there twice. That's called a multiplicity, and we will get to that later as well. Multiplicity of 2. That's because it showed up twice in the solutions list. All right, 2 is a solution. 2 minus 2 is 0. To find the solutions here, you'd have to use the quadratic formula. So x equals negative 2 plus or minus square root 2 squared minus 4, 1, 4, all over 2 times 1. that would be the square root of 4 minus 12. So the square root of negative 8. Again, you can go back to the lesson on simplifying square roots here. So you'd have x equals negative 2 plus or minus 2i square root of 2. And since all of these are divisible by 2, I'm looking at the pieces that I'm going to highlight here in this bright color. Those are all divisible by 2. We can divide them all by 2. So x equals positive negative 1 plus or minus 1i square root of 2. And so for our solution set, we have 2 answers there, 1 answer there, 2 answers there. So we have a total of 5 solutions, right? Next, rational equations. All right, so these look familiar. We said with any equation with fractions, our workflow is going to be to get rid of the fractions first, and that doesn't change here. We still want to get rid of the fractions. The key here is we do need to make note of things that x cannot be, because one of the major rules in math, one of the fundamental rules in math, is that you cannot divide by 0. So x can't be 4, and x cannot be negative 2. If we get those as our answers, and whatever makes that 0, I don't know what makes that 0 yet. That looks like a trinomial though, so what we can do is we can try and factor it right, and if we use star method to factor that, we end up with x plus 2 and x minus 4, which is the exact same 2 factors that we just had, right? So x still can't be negative 2 or positive 4. I'm going to list those out to the side here, negative 2 and positive 4. If we get negative 2 or positive 4 in the end, x cannot equal negative 2 or positive 4. If we get either of those answers, we have to toss them out. We can't use them. And I'm just going to replace this here on the bottom because I factored it. I'm going to replace it with what it's equal to, x plus 2, x minus 4. And now our distinct denominators here, x plus 2 and x minus 4. That's what I need to multiply every fraction by, x plus 2, x minus 4. X plus 2, x minus 4. And it doesn't matter what order you're doing this in. Because remember, that's x minus 4. Because remember, once you have them listed out, you're actually going to start getting rid of the things that match up top to bottom, right? Those will divide away. Just like 5 over 5 is equal to 1, x plus 2 over x plus 2, x minus 4 over x minus 4. Those are just equal to 1. We can divide them away. We're going to multiply what's left, so 2x times x plus 2 minus, I'm bringing down that minus sign, 3, x minus 4. Bring down that equal sign. X squared plus 14 has nothing left to multiply with. All right, let's see what we got here. We can distribute 2x squared plus, that's going to be a 4x. Let's clean that up a little. 4x minus 3x plus 12. This negative 3 has to go to both. Equals x squared plus 14. And I'm going to try and get everything to one side equal to 0. And we can combine those like terms in the same time. So x squared plus x, that's going to be a minus 2 equals 0. We could do star method here. Negative 2 on top, 1 on bottom. Positive 2 and negative 1 will multiply to negative 2 and also add to positive 1. So that would be x plus 2. X minus 1. Negative 2 would make that 0. Positive 1 would make that 0. So those are our 2 answers, but we do have to look at our restrictions here is what they're called. If the question ever asks for the restrictions, if it only asks for the restrictions, then you could just stop at that step. You don't have to go through and solve the whole way. But if it asks for the solutions, you still need to keep up with the restrictions because in the end, here we have to get rid of one of those answers. Negative 2, we just said x cannot equal negative 2. So we've got to get rid of that answer. Our only answer that works here is 1. As always, you can go back to the original equation, back before you changed anything. Sub in a 1, which is our solution. Check it and make sure that it works. All right, we've got also some word problems here. Alina takes a boat 6 miles downstream with a 1.5 mile per hour current. That's going downstream. She has a 1.5 mile per hour current. The return trip against the current takes an hour longer. She's going the same exact distance, right? She's returning to the same place, but it takes 1 hour longer. Find the speed of the boat in still water. This has speeds, it has times, it has distances. So I think we're going to have to use that distance equals rate times time formula. And if we just move some things around as if it was a literal equation, we can have it solved for t. So the amount of time that it takes to go upstream plus the amount of time that it takes to go downstream takes a total, oh, we don't know how long it takes. It takes 1 hour longer though. Okay. So our time with current, I just have all these things labeled. Our distance is 6. Our rate is 1.5 plus whatever our boat's going, right? And our time, I just solved again for t here so that I could have time listed. On the way back, our distance is still 6. She's driving the same 6. The current is hurting you. And a time, again, I just have that solved right here. D over R. All right, our time on the return is equal to our time there plus 1. It says the time on the return trip takes 1 hour longer. The time on the return takes 1 hour longer. That means if this is 5, that has to be 6, right? If this number has to be larger, that's why I'm adding a 1 on this side. If our time there was 5, our time in the return would be 6. I can substitute in the t values that I have here, right? So the time in the return, that's here. The time there, that's here. And then I'm going to solve it just like I solved the one on the last page, right? Trying to get rid of the fractions first so we can multiply by b minus 1.5 and b plus 1.5 in each place. You end up with something that looks like this. B plus 1.5 after you get rid of the piece you don't need. B minus 1.5 when you get rid of the piece you don't need. You need both here, B minus 1.5 and B plus 1.5. Once you get to this point, you just want to get everything to one side and equal to 0. In this case, all the b's go away. You've got a minus 1.5b and a plus 1.5b. Those two things just cancel out. You've got a 6b, and when you subtract 6b, those things cancel out as well. And now you can just take the square root of both sides. You end up with b equals plus or minus 4.5. That's the speed of the boat, and we got to ask ourselves, does it make sense for a boat to be going negative 4.5 miles per hour? No, it doesn't. So we're going to call that 4.5 miles per hour. It says find the speed of the boat in still water. So if she was going upstream, she was going 4.5 plus the 1.5, right? When she's going downstream, I'm sorry, she's going faster. She would be going 6. When she's going upstream, she's going 4.5 minus 1.5, so she'd only be going 3 miles per hour when she's going without the current, against the current on the return trip. All right, the next type of equations that we're going to solve, like I said, this is just other equations, right? So we have absolute value equations as well, and then in a minute we're also going to have square root equations. So now with absolute value equations, the way that we're going to break this up almost always is we're going to be looking at this line right here. So whenever we have an absolute value, it's going to be equal to that number or the negative number. These down here absolutely help, right? So if the absolute value is equal to 0, we're only going to end up with one solution. We're looking for where it equals 0. If the absolute value, if you ever have an absolute value equal to a negative number, it's going to be no solution. That's because an absolute value always turns things into a positive, right? You can't ever have something in an absolute value that's turned into a negative. So I would absolutely make note of this one. We're going to have some corollaries to that in the next lesson about inequalities. But typically, if you're given something like absolute value of x equals 5, you're going to end up in a scenario like number 1, where if absolute value x equals 5, then either x equals 5 or x equals negative 5, because the absolute value of 5 is 5, and the absolute value of negative 5 is 5. So you end up with two solutions, typically, with absolute value equations. Now, with absolute value equations, you do want to go back and check your answers, because sometimes you have some that are extraneous, some that just don't work when you get to the end. All right, the key to these is, the first thing you want to do is get that absolute value by itself, the absolute value by itself. So here, if I divide both sides by 2, I'll have the absolute value by itself. That would be now absolute value, 3 minus 2t equals 3. And now that it's by itself, now I can split it into two parts. You're never going to mess with the thing that's inside the absolute value here. I'm never going to mess with that, but I'm going to change everything that's outside. If there are any numbers outside, I'm going to change those. If there's variables outside, I'm going to change those. I'm always going to make them the opposite sign. So here I'll have 3 minus 2t equals 3. That's one equation. And then I'll have 3 minus 2t equals negative 3. The exact opposite. Remember, I'm only changing that. One is going to be the same. One is going to be the opposite. And now I just need to solve each of those equations to try and get my solutions. So subtract the 3. Minus 2t equals 0. Divide by the negative 2. T equals 0. That's one of my solutions. All right, again, subtract the 3. Negative 2t equals negative 6. Divide by the negative 2. T equals 3. Those are my two solutions. You always can go back and check those in your original problem. Same thing here on B. I want the absolute value to be by itself first. So the first thing I'm going to do is subtract 8. And you get negative 6 equals absolute value 7w minus 3. You can go through and solve and solve and solve and get w equals some number and some other number. You can go through and solve. And then when you checked, the numbers would not work out. The reason I know it's not going to work out already is because of what I circled up here. If you have an absolute value equal to a negative, it's going to be no solution, right? You can't take an absolute value and get a negative number. So once I get to this point here, an absolute value equals a negative number cannot be true. This is going to be no solution. If you did not see that from the beginning and you just went through and solved, when you checked your answers, they would not work. You would end up with something like 6 equals negative 6, which is not true, okay? So then you know, again, that it's no solution. All right, here are some more practices. Again, I would suggest pausing this, trying to work through on your own. On this first one, the first thing we're going to do is divide by the 5. Then we're going to break it into two equations. Again, the only thing we're changing is what's outside. Once we break it into two equations, we can solve each and have two solutions. You'll want to check those solutions. On the second one, to get the absolute value by itself, you can subtract 9. You can solve, solve, solve. You end up getting two answers, and if you check those two answers, neither of them work. Neither of them work. That's because you have an absolute value equal to a negative number, so we're going to have no solution. Neither of these two answers that we got work. They don't work. If you ever have an absolute value equal to an absolute value, you're going to do the same exact thing, but even though one of them is in absolute values, you're going to have to make one of them different. I always just keep the first one, right? So here's how we're going to do it. We're going to say 2x minus 5 equals x plus 1, and 2x minus 5 equals negative x minus 1. I'm changing everything in there. So then to solve, I can subtract x. X minus 5 equals 1. Add the 5. X equals 6. That's one solution. Here, add the x. 3x minus 5 equals negative 1. Add the 5. 3x equals 4. Divide by 3. X equals 4 over 3. And that's my second solution. We get two solutions. We should check them and make sure they work. In this case, I believe that they will. The same thing on the second one if you want to pause it. Here's your two equations. Here's the solution to the first. Here's the solution to the second. Notice on the second one, we just get 6 equals 6. If you go back and watch, there's a video in week 1 about the types of equations, right? There's conditional, there's identity, and then there's contradiction. This one right here is an identity. And what that points to for us is that our solution set is all real numbers. That means there's not a number that we can plug in here that is not going to be true. We can pick any number, so I'm just going to pick a random number. Let's say we pick 10, right? Then what I would have is absolute value 6 minus 10. I'm just seeing if it works. So that'd be absolute value of negative 4 equals absolute value of 4. And what we get is 4 equals 4. it does check out. Remember, I just picked a random number, 10. Doesn't matter which number you pick there, this is going to work out. Every real number will work. That's because we got an identity equation. So yes, 6 is a solution, but also every other number in the world is a solution. Every other real number is a solution as well. All right, the other type of equations we're talking about is radical equations. That's equations with rational exponents or equations with a square root in them. To get rid of a root, we're always going to use a power. Just like a plus will get rid of a minus, a multiplication will get rid of division, a power will get rid of a root. They have to have the same index, and by index I mean this number right here. So a third root, a third power will get rid of it. A square root, that's an understood 2, a square will get rid of it. If I had a fifth root, a fifth would get rid of it, fifth power. You know that anytime you do a even power, it's going to turn something into a positive, right? And so with these, you also want to go and check your answer. You really want to go and check your answer with any, especially if they have an even root and you're having to do an even power. All right, here's our workflow. Again, we want to get, just like with absolute values, this stuff by itself. We want that to be by itself. So we'll add the 4. That'd be square root x plus 10 equals x plus 4. To get rid of the square root, we can square both sides. And what that means here is x plus 4, x plus 4. And then we'll have to FOIL to get our next piece. A square and a square root get rid of each other, so we just have x plus 10. On the right side, if you take that and FOIL it out, you get x squared plus 8x plus 16. Now let's get everything equal to 0. So subtract x, subtract 10. We get 0 equals x squared plus 7x plus 6. We can do star method. 7, 6, 1 and 6, multiply to 6 and add to 7. So that'd be, you saw how quickly I did that, and that's because I've done this method a million times. You need to be that fluent as well, where you can just go and check very quickly. All right, we do on this, we want to check our answers here, okay? You really want to check your answers, and you want to go back to the original to check your answers. So if you sub in a -1, you would have square root -1 plus 10 minus 4 in your calculator. On the other side, you would have a -1. All right, on this side, that would be the square root of 9 minus 4, that would be 3 minus 4. In the calculator, this would give you -1 equals -1. Check. That works. Check the -6 as well. Square root -6 plus 10 minus 4 equals -6. Here, that would be the square root of 4 minus 4 equals -6. That would be 2 minus 4 equals -6. That is not true, right? We get -2 equals -6. So that solution does not work. Odds are on these, you're pretty much almost always going to have one solution that does not work. If you get 2 solutions, one of them won't work. That happens a lot. Sometimes they will both work, but a lot of times they do not. All right, this one I have already worked out because it is so much work. If you have 2 square roots, you're going to do the same thing. You have to get one of the square roots on a side by itself. So the first thing we're going to do is move that over by adding it. Once we do that, you can square both sides. When you square this side, you're foiling it. That's what I have listed over here. You're foiling that. On the left side, when you square it, it just gets rid of the square root. This is what that looks like after you FOIL it and combine like terms. Again, we want to combine like terms and get another, we have another square root now. We want to get that square root by itself. The way you can do that is combine those as if they're like terms. That's 2 of something minus 2 of something, and you end up with 4 of those things. Move all this stuff to the other side. Divide by the -4. You can again square both sides. That means you're foiling here. Oh my goodness. Okay. After you FOIL that, that's what it looks like. Combine like terms. Get everything to one side. Make it equal to 0. Do your star method. That's what the factors look like. Those are your 2 solutions. and you will want to check those two solutions. I'm going to leave it to you. When you check those two solutions, I think it's highly likely that one of them is not going to work out. It seems to me like the 1 is going to work out, right? That would be 0 minus 2. It seems like the 1 is going to work out. Maybe the 5 won't work out, but I'll let you check that. All right, if you have an exponent that's a fraction, a way to get rid of that, if I had x to the 2/3 here, for example, I can do that to the 3/2 exponent. Let's just give that a shot here. So what we can do first is divide by the 2. The next thing we can do, I'm worried about the pluses or minuses here. I think that's going to throw us off. What we can do is do everything to the 3rd power, And if we do everything to the 3rd power, this 3 and this 3 will go away. X plus 1 squared equals 8. Yeah, this is what I was thinking. All right, so when we take the square root, we're going to get a plus or minus. All right, I did that work just to ensure that we were going to get the right answer here. Equals, we divided by 2, we get 4, right. So to get rid of that, what we can do is both sides to the 3/2, And if you ever take both sides to a power with a bottom that's even, you need to get a plus or minus on that side. On this left side, these two things undo each other. That's the purpose of doing that. The powers that are opposite, the purpose of that is that they undo each other. 4 to the 3/2 is 8. You can type that in the calculator, 4 to the 3/2. And then we can subtract 1. X equals -1 plus or minus 8. -1 plus 8 is 7. -1 minus 8 is -9. Again, we got 2 answers. We should check both of those. I'm trying to mentally check, but I can write it down. 2 parentheses, 7 plus 1 to the 2/3 equals 8. I don't know. Let's see. That'd be 2 times 8 to the 2/3 equals 8. 8 to the 2/3 would be 4. And yes, that does work. How about -9? 2 parentheses. -9 plus 1 to the 2/3 equals 8. 2 times -8 to the 2/3. -8 to the 2/3 is 4. And 2 times 4 does equal 8. So it seems like both of those work. Great. All right, we have other equations where they don't look like a quadratic, but they are a quadratic, right? If I look at this as if this is something squared and this is something, if this was x squared plus 36x plus 35 equals 0, you would know how to solve this equation, right? I could even change the variable out and say, if this was u squared, right? If this was u squared plus 36u equals 35 equals 0. With this, all we would do is star method. And that's exactly what we have. This thing that I have underlined, we're going to call that u, okay? This method is called u substitution for a reason, because what we're going to do is, if we call that u, we can rewrite our equation to look like that. If you rewrite it to look like that, you could do star method. And multiplying to 35 and adding to 36 would be 35 and 1. So that would be u plus 35 and u plus 1. Well, we know that u is equal to 2x squared plus 3. So if we sub that back in now, here and here, combine our like terms, and now we can take each of these and solve them separately, okay? Now that we have it broken down, this is much easier. Now that we have this broken down to here, we can now solve each of those. 2x squared plus 32 equals 0. 2x squared minus 2 equals 0. I'm just taking each of those, setting them equal to 0 and trying to solve them. So then 2x squared equals negative 32. I subtracted the 32. Divide by 2 on both sides. X squared equals negative 16. Take the square root on both sides. And x equals plus or minus 4i. That's two solutions. On this one, 2x squared equals 2. You can add 2 to both sides. You can divide by 2 on both sides and get x squared equals 1. And then, when you square root on both sides, you get x equals plus or minus 1. It would really help you to go back and review your simplifying. There's a video on simplifying radicals. There's a video that will help you out here. There's a video on solving quadratics that will help you out here as well. Both of those videos sort of tie into this. That was actually the last lesson that we did. All right, same exact thing here. This does not look like a quadratic, but move everything over to one side. It looks a little more like a quadratic. As long as this exponent is double that one, we can do a similar u substitution. If u is w to the 1/3, then this first one is u squared, and the second one is just u, right? Then we could do star method again. All these things match up with our u's. Substitute the u's in, and then solve them just like we were doing on that last page. So w to the 1/3 minus 4 equals 0. W to the 1/3 equals 4. We can do a third power on both sides. Remember, a power will get rid of a exponent, right? 1/3 times 3 would make 0. That would be w equals 4 to the 3rd, which is 64. On this side, 2w to the 1/3 plus 5 equals 0. Again, to get rid of the 1/3 power, well, first let's get rid of the 5. So 2w to the 1/3 equals negative 5. Now divide by 2. W to the 1/3 equals negative 5 over 2. Now if we do the third power on both sides, w equals negative 125 over 8. We got two solutions. You'll probably want to go back and check those. I think in this case both of these work. Again, with all of these, you should go back and review factoring. You should go back and review simplifying radicals. You should go back and review solving quadratics. Those three topics are really going to help you with this type of equation.